Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about setting up a very basic hull for hydrodynamic analysis in the ProteusDS Rhino3D toolset. We're going to use Rhino to create a very simple box barge and import that into the Rhino3D toolset. So this is Rhino, and what I'm going to do is just create a new project with large objects in meters. Now, you don't have to use Rhino to create a hull mesh, but it's very commonly used and found in a lot of companies in the marine industry and in naval architecture companies. So it's kind of handy to have and use for things like this. Now, the first thing to note is that the Rhino3D toolset is expecting a file input in a certain format with a certain reference frame configuration, and we strongly recommend you set everything up with the origin of the frame at the aft perpendicular of the vessel. That'll make it really easy to key in particulars for the ship in the future based on station number, which will be keyed from either the forward or aft perpendicular accordingly. The other thing that the Rhino3D toolset's looking for is a positive Z up and the location at the baseline of the vessel. So for our box barge, what that means is we are going to be creating a system with the frame at the bottom and the aft the transom of this little box barge. So it's all arbitrary. We're going to arbitrarily make this a 20 meter by 20 meter box. So we'll go Y of 20. I'm just looking down here at the coordinates here. You may find that grid snap is helpful for this as well. So we'll go to Y to minus 10 on the other side, and then we want X 20 here. So there's our little box, and then we will, looking at the Z view here, we'll make it 2 meters tall as well. So we make it 2 meters tall, and there's our little surface. Now the thing is, Rhino primarily works in surfaces. This is not a mesh that we can use for hydrodynamics analysis, so we need to create a mesh. And the first thing you need to do is select the whole thing and explode it so that we have surfaces on all of the facets of this structure. And then we can go to Mesh Tools over here. And we're going to go to Mesh from Surface, Polysurface. Now, what you can do is you can kind of constrain the element sizes using the minimum and maximum edge lengths. I've got 1.5 here. Click Preview to get a look at it, and you'll get some experience in working with systems like this. Over time, you want to have relatively, square kind of faces on your mesh for your hull and that sort of thing. And definitely not too many, because it really will increase the computational effort for the calculations that need to be done. But this is definitely more than enough. So we'll go OK, and we've created our mesh. Now, before we can actually use it, we have to get rid of the poly surfaces as well. So what I like to do is click on Filter Select, and if you just have surfaces selected, that will work, but what we can do is just get rid of meshes. I think that will work. So if we select all this, there we go. It's got all the surfaces, but not the mesh itself, and we can delete that. Now, this is a good time to save your Rhino project here, and the reason that it is a good time to save is that we can use this for visualization purposes in the future. So we'll just go to Ship Motion Projects, Square Barge. I'm going to call this Hull for the whole thing. And I'm also going to save an OBJ mesh of the full thing. And we'll use this in a future tutorial on visualization. So we'll go save. Note some options will come up. They're all usually fine with the defaults. Make sure this map Rhino Z to OBJY is not checked, because that will flip the reference frame around and make it confusing to work with. Okay, now the other expectation that the Rhino3D toolset has is you're only providing in half of the hull, and it'll automatically get mirrored within the hydrodynamic process itself. So we can cut this in half pretty easily. We'll just pick a surface here, and then in the ZX view here, just pick some points that As long as it encompasses the entire section here, we're good. So now what we want to do is go back to mesh tools, and then we've got mesh trim. And we'll click on that. And it says select cutting objects. So we're going to select this face here. We click enter, and then it says select objects to trim. Just beware, if you've left this selection filter open like I have, you'll need to select meshes back on there again. Okay, and we want to keep everything in the positive quadrants, and we can delete things that are in the negative Y direction here. So just click on all of the details there, and it's looking good. So we've got half of the mesh there. Okay, great. Now press enter to finish the mesh trim process, and we can get rid of this cutting surface as well. So one last thing to check is also the normal directions. You can see more on this in another video tutorial, but I've configured everything in shaded view to show red on the inside, so we know we have the normals facing the right way, which is great. Okay, so now what I want to do is we'll save as. You can either save as OBJ or you can export. I think there's an option here, export selected. You can select what you want and then go export selected, and we'll pick OBJ out of this list. There we are. And we'll go hull half. Go into ship motion projects. There. The same options will come up, and we will go OK. Okay, we're all done with Rhino for now, and I'll show you how to bring this into the Shipmo3D toolset to start the process of the hydrodynamic analysis. So we'll make a new project. What we'll do is we will save it in Ship Motion Projects Square Barge folder. We'll call this Square Barge. And length between perpendiculars, that's going to be 20 meters. Draft at midships, and remember it's 2 meters tall. Arbitrarily, we're just going to make it 50% submerged, so 1 meter. Height of CG above baseline. This is important to keep track of too, because this is where about the center of mass is where all of the hydrodynamic coefficients are going to be resolved in the calculation process. So it's important to know that. We won't be doing anything with rudders or propellers in this. We'll set those to 0. And the first thing we do is we want to load in the mesh. We're going to use the first application, panel hull. So we'll go add new data, panel hull. Let's just close this first. So it didn't save the information in the project because I didn't save it yet. So we'll save this. Okay, now when we do add new data, it should show up accordingly. Here we have the height of CG and draft at baseline. It's looking good. Okay, so you have your option for input, either patch hull or OBJ file. And we want to click and select our half of the hull, and we run it. It looks like it's run successfully, and when we plot the panel hull, it's showing the mirror imaged portion there as well. I like the ship parts color view here because it shows the dry and the wet hull really nicely. Just adjust the view angle there. Note also that Shipmo3D will automatically refine the mesh around the waterline for you. That helps significantly with the quality of the hydrodynamics calculations. And if you change the displacement values in here or the trim, you'll see a different wetted hull area. Just beware that you'll have to go through the calculation process, which we'll show in another step shortly. So the next step after this is getting into the radiation and diffraction hydrodynamics analysis process. In the meantime, thanks for watching.